Now we will discuss about distillation under reduced pressure. When we take simple distillation or fractional distillation, the liquids were not decomposing at their boiling points. But there are certain liquids in practical life which decompose at their boiling points. So for those kind of liquids, we use distillation under reduced pressure. So this technique is used for liquids which have high boiling point and which decompose at their boiling point or less than their boiling point. So if they decompose, then we don't have the same liquid and we can't get the same liquid as a distillate. So that is the reason what we do is we just try to vaporize them lesser than their boiling points. We know this concept like boiling point of a liquid is directly proportional to the pressure acting on the liquid, right? So what we try to do is we reduce the pressure here so that boiling point of the liquid falls down. So we will boil the liquid at a lower temperature than its usual boiling point. So there won't be any problem of decomposing and the liquid vaporizes and will be collected. And here we will be using three parts of apparatus. One is water condenser, and then is receiver. Water condenser is used for condensing the vapors of the liquid and receiver to receive the distillate, and here we use a vacuum pump. The job of vacuum pump is to suck out the air so that the air pressure is reduced. When the pressure acting on the liquid is reduced, automatically the boiling point of the liquid is also reduced. And with the help of vacuum pump, we can obtain 0.1 mm of Hg pressure. So we can obtain a least value of pressure as well. And we can also maintain 10 to 20 mm of Hg pressure so that the boiling point of the liquids can be lowered. So what are we going to do basically here? The liquid mixture is heated at reduced pressure. Why are we reducing the pressure and then heating the liquid? Because with the help of reduced pressure, we can boil the liquid at a lower temperature. So now liquid boils at a lower temperature. And why are we not boiling at its normal temperature? Because at its original boiling point, it decomposes. That is the reason. For example, if I take glycerol, actual boiling point is 563 Kelvin at 180 atm pressure. And the problem with the glycerol is it will decompose at its boiling point. So how can we collect the glycerol without its decomposition? With the help of reduced pressure. So what we do is here we maintain a pressure of 12 mm of Hg instead of 180 atm. 180 atm in the sense what? 760 mm of Hg. You can see the difference here. Under 760 mm, its boiling point was 563. Now we are bringing a change in pressure. We are lowering the pressure to 12 mm of Hg. Now at this pressure, the boiling point of the glycerol will be 453 Kelvin. Now the boiling point is lowered. Now the glycerol will boil at 453 Kelvin itself. We collect the vapors, we cool the vapors, and then we collect it in the form of distillate. The other example, sugarcane concentration. Sugarcane is concentrated with the help of same technique, that is distillation under reduced pressure. And glycerol from the spent lye. From the mixture of glycerol and spent lye, how glycerol is separated with the help of same technique. When we take soap industry in the saponification process, glycerol is along with some alkaline content. So how this glycerol eliminated, removed from alkaline content with the help of distillation under reduced pressure. Let us see this diagram. This is the experimental setup for distillation under reduced pressure. So we have a Bunsen burner for heating the mixture. We have the round bottom to flask, and we have a capillary here to regulate the air. Okay, and we have a manometer which measures the air pressure. Okay, basically manometer is used to measure liquid pressure, but here we regulate the air, and whenever there are changes in pressure we can see the changes that are taking place in the liquid pressure. So indirectly we are keeping a check on air pressure here. Okay, and vacuum pump, so this is used for what? Sucking out the air so that pressure levels will be dropped down for the liquid mixture. Now we just do the same process, heating process. So here the liquid gets boiled at lower temperature. Why is it so? Because we are reducing the pressure with the help of vacuum pump. So all the air which is present here, that will be sucked out. So we are providing a very less pressure. So if I take the example of glycerol, how much pressure are we providing here? We are providing just 12 mm of Hg pressure. Now at this pressure, the glycerol is vaporizing at what temperature? 453 Kelvin temperature, lesser than its usual boiling point. What is its usual boiling point? Its usual boiling point is 563 Kelvin. So we are boiling it, we are collecting the vapors of it without any decomposition of it. And how are we able to achieve this? With the help of reduced pressure. So vapors start entering into the condenser, and there will be water circulation here, and so cooling process takes place. Now these vapors will turn into liquid, and this liquid will be collected as the distillate. If there are any doubts, please let me know. Comment in the chat section. Thank you.